Status check to proceed with terminal count.
There is a moment at the start of every mission when everything comes together. A moment when years of preparation and planning are put to the test.
Clear to proceed.
There are no second chances.
You have permission to launch.
Success or failure is just a heartbeat away.
Rock report range status. Range green.
A spacecraft and its rocket on the pad, fully fueled and ready to launch.
Status check. Go Delta.
In that
PSP.
moment, a controlled explosion is released with such intense power, it can propel a spacecraft off the Earth and into space for the benefit of all. We call this moment T0.
Parker Solar Probe,
This
a
is
daring
its
mission to
story.
shed light on the mysteries of our closest star, the Sun.
The Sun, the heart of our solar system. It's as familiar as anything we know. Although the Sun has been studied for millennia, it still holds unsolved mysteries about its effects on our daily lives. To better understand the Sun, NASA is preparing to launch a spacecraft called the Parker Solar Probe. It will lift off from Cape Canaveral Air Force Station near the agency's Kennedy Space Center, located in Florida. It's a mission of unprecedented opportunities that could revolutionize our understanding of our star and the Sun's atmosphere, the corona, a long-time destination goal for scientists such as Dr. Nikki Fox.
Going into the Sun's corona for the first time, going up close and personal with our star, to be able to answer some of the mysteries that live in this coronal region. Why is the Sun's corona hotter than the surface of the Sun? Why is there a solar wind? Why does this atmosphere, this corona, become so energized that it can move away from the Sun at supersonic speeds and bathe all of the planets?
And now that Parker has finally arrived on the Space Coast, we're one step closer to solving those mysteries. Delivered on an Air Force C-17, it's not every day this crew hauls a payload destined for the history books.
Overall, the mission itself is relatively simple. I'd say the biggest challenge is probably the load portion.
A little extra to it too, because normally we're just hauling generic things, but not a $1.5 billion solar probe.
And there's only one world-class program that specializes in missions of this caliber, NASA's Launch Services Program, a team that matches the industry's top-performing rockets with the cutting-edge spacecraft NASA is committed to launching.
LSP is NASA's bridge to space. Basically what we do is we link a spacecraft customer such as the Parker Solar Probe up with a launch vehicle provider such as United Launch Alliance. And we provide them with a custom-built ride to space on a carefully selected launch vehicle.
Engineers and scientists with Astrotech and the Applied Physics Lab teams will spend its last few months checking and testing every element and completing final assembly to be sure it is ready to leave Earth for its epic trip to the Sun. Parker must be perfect before T0 arrives.
Before we start integration with the launch vehicle, we have to do final integration of the spacecraft. That includes attaching the magnetometer boom and magnetometers. We'll then also integrate the solar arrays. And then finally, right before integration with the launch vehicle, we'll add the thermal protection system or thermal shield.
The Parker Solar Probe will be the first mission to kiss the Sun, flying through the searing heat of the Sun's corona, traveling closer to the surface than any other spacecraft before. And to do that, it will need to go faster than any other spacecraft in history. That's why, for the first time ever, NASA's Launch Services Program selected the United Launch Alliance Delta IV Heavy rocket.
Parker Solar Probe will be the fastest human-made object ever. We are traveling at an unbelievable 430,000 miles per hour.
NASA selected Delta IV Heavy for the Parker Solar Probe mission because of the combined energy of the booster, Delta cryogenic second stage, and the third stage, which means that we have enough energy to go to the Sun.
I mean, if you look at the vehicle, it's huge. It's approximately 50 feet wide, 170 feet long, and about 190,000 pounds.
Going out and seeing the Delta IV Heavy on the pad is a truly awe-inspiring experience. Just seeing that amount of raw power right in front of you is just incredible. 3 boosters, our second stage, and then we have a third stage. We're a tiny little spacecraft. We look like a little hood ornament on the top of the Delta IV.
Throughout its 7-year mission, NASA's Parker Solar Probe will swoop through the sun's atmosphere, carrying more than scientific instruments on this historic journey to the center of our solar system. It will also hold a piece of humanity itself. Back in March 2018, the public was invited to submit their names. Over 1 million were loaded into a memory card and mounted on a plaque bearing a dedication to the mission's namesake. Dr. Eugene Parker was a heliophysicist ahead of his time. He proposed this mission back in 1958 after discovering the existence of the dangerous and unpredictable solar wind.
The reason it has taken us 60 years to be able to fly this mission is not because we weren't interested. It really is because it has taken that long for technology to be developed to allow us to do this incredible mission.
During the Parker Solar Probe's perilous dive into the sun's corona, the atmosphere, it will navigate dangers never before experienced by a NASA deep space mission. 3 million degree plasma, sporadic solar flares, and delayed communication with Earth. Traveling this close is only possible because of the spacecraft's protective heat shield, the single largest piece of hardware and the most critical to mission success. One slight error in its performance could cause the probe to melt and the mission would be lost.
Parker Solar Probe is actually going and touching the sun. When we actually get to our closest approach, the heat shield on Parker Solar Probe will be at about 2,500 degrees Fahrenheit on the front surface. The back surface is going to be at about 600 degrees Fahrenheit, but then the spacecraft bus will just be operating at a normal room temperature almost. It's a little bit higher, about 85 degrees. The previous missions have been really important for solar science as we study from afar, and we can learn a lot from studying from afar. But the Parker Solar Probe is actually going and touching, almost kissing the sun, so we can learn so much more.
The spacecraft is now ready for flight, but it can't get millions of miles to the sun unless it gets a boost from a specially made third stage by Northrop Grumman.
The Northrop Grumman third stage team specifically designed and built this third stage for the Parker Solar Probe mission. The Parker Solar Probe needs a third stage because even though the Delta IV Heavy is an incredibly powerful rocket, the third stage is what gets it the extra boost to get into its final orbit around Venus and to the sun.
Parker Solar Probe is the hardest trajectory that I've ever worked on for a couple of different reasons. One, we're flying on the Delta IV Heavy, which is the largest and most complex rocket that Launch Services Program has ever been involved with. And in addition to that, we're flying a third stage that has its own guidance, navigation, and control system on board. So from a trajectory, GNC standpoint, it's like flying 2 missions at once. Parker Solar Probe it's called a heliocentric orbit, which means it's orbiting around the sun. And using a gravity assist, usually we use that to add energy to the spacecraft's orbit when we go out to places like Jupiter or Saturn or Pluto. In this case, we're going in the opposite direction. We're heading inside the orbit of Mercury. The folks at Applied Physics Lab have come up with a very unique trajectory where the spacecraft is going to use the mass of Venus to slow themselves down. And not only are they doing that one time, they're actually going to do that 7 times in a row over a space of 6 years in order to get the spacecraft perihelion, because we're orbiting the sun, down below 10 solar radii. So when we're in orbit around an object, whether it's the Earth or the sun, we go fastest when we're closest to that object and slowest when we get to the top of this orbit. And therefore, when we pass very close to the sun, which is the most massive object in our solar system, we are going approximately 430,000 miles per hour relative to the sun. This really is rocket science.
During the early stages of launch, the Parker Solar Probe will be encapsulated in a large payload fairing. The Delta IV Heavy is a massive rocket designed to launch a school bus-sized spacecraft. The last step at Astrotech is safely securing the 1,510-pound spacecraft in a fairing that, by comparison, makes the probe look small.
To get to the sun, we actually need a lot of energy. Because of that, we need a very large launch vehicle. And in fact, we have the biggest launch vehicle we can get. And because of that, the fairing that is associated with this launch vehicle is very large. But because we're a small spacecraft, we take up a very small amount of space in that fairing. And that's the reason why it looks like we're a very small spacecraft on a very large vehicle. But once the spacecraft is encapsulated, that's it. We no longer get to touch it.
The encapsulated probe is now ready for a slow, steady ride to the launch pad at Cape Canaveral. It will be transported atop a K-Mag made for transporting special payloads. It can hold thousands of pounds, spin 360 degrees, and keep its payload level when traveling up inclines.
One of the nice parts about the K-Mag that we have is it has very precise steering capabilities, and it also has a lot of different steering capabilities. So it gives us a lot of capability to get into a precise location, both for hoisting operations down in the hoistway, as well as different mating operations in our horizontal integration facility.
Now, the ULA team will carefully lift the Parker Solar Probe safely nestled inside its payload fairing to mate it atop the massive Delta IV rocket. To keep the payload safe during the entire lifting operation, there's a special channel constructed in the tower itself known as the hoistway that allows the payload to be lifted without any influence from adverse weather or environmental conditions.
The exciting part about today is it's when we finally get the customer out here, we get the spacecraft hoisted, and that's what it's all been about. A heavy mission by itself is always exciting, but then you add in the factor of having a NASA exploration mission, the mission to touch the sun. That accompanied with the heavy, it's just an exciting launch for the public, a great exciting launch for ULA. It'll be a lot of fun to see, and it'll be a lot of fun to track over the next several years as it gets into its final orbit around the sun.
NASA's Launch Services Program has now brought together the payload and its ride to space. After taking different roads to the launch pad, finally the spacecraft and the vehicle are together.
Goddard runs all of the Living with a Star missions, and this is what's called a flagship mission. It's one of the most important things that our science does. So the anticipation of launch is just tremendous. I've been working on this project for 10 years, and now to see it actually ready to go, it's just a tremendous feeling. It's really hard to describe.
Now, as T0 is just days away, it's up to ULA and LSP to make sure they're operating as one. In the hours before liftoff, the mobile service tower gantry rolls back, leaving the mighty Delta IV standing on its own, ready for launch. The final countdown to T0 is underway.
As the NASA launch director, ultimately what I do is give the go or the no-go. That's a very simple statement, but there's a lot that goes behind that. It's a culmination of a bunch of professionals that know their jobs, they know it well, and all I have to do is make sure all those pieces are in place. Then it's easy for me to make the decision to launch.
Thousands of rockets have launched from Florida's Space Coast, but this is the first designed to fly to the sun. Big Delta IV Heavy rocket is ready to roar to life with more than 2 million pounds of thrust to power the Parker Solar Probe on a trajectory of millions of miles to its destination.
Proceed with terminal count. First stage systems. Propulsion. Go. Hydraulics. Go. Locks. Go. Launch director. You have permission to launch. Status check. Go Delta. Go PSP.
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
All 3 RS-68s look good in the full thrust mode. Response looks good. Vehicle trajectory looking good, right down the middle of the range track.
T-3. Engine start. 2, 1.